And the last couple of types of crystalline structures are something called orthorhombic. Orthorhombic means you have a prism, but its base is a rhombus, okay? And you guys are used to seeing, let me take this down a little bit, used to seeing sulfur in a powder form, but you can treat sulfur so that it forms crystals. And the way you do that is you take the element and you put it into solution, heat it up so that it actually, you force it to sort of dissolve in water, and then you slowly evaporate off the water, and that will give you crystals. So you can do this with sulfur, and one of the forms of sulfur that you can have is this orthorhombic, which are these rhombus-based prisms, looks something like that. Another example of orthorhombic crystals are aragonite, this stuff. You can kind of see it a little better here. They are like four-sided shapes, but they're not, definitely not squares, more like rectangles, rhombuses. Okay. All right, and then the last type of crystal that you might have are these monoclinic ones. This is also sulfur, and you'll find that in the assignment I'm going to give you, that depending on how you treat the sulfur, you can create both of these crystals with it. And so these are the monoclinic. These are needle form, needle-like crystals. Okay. All right, this is another one, azurite. Kind of beautiful, needle-looking crystals. Okay. And those are monoclinic crystals. And then you need to know this term, the unit cell. The unit cell just refers to the very smallest particle that actually forms the shape of the crystal. And all the other molecules or atoms lay themselves down once that pattern is formed. They attach themselves in the form of that pattern, so you get bigger and bigger crystals. If any of you have ever made crystals, when you were a little kid, sugar crystals or anything, you could watch them. I mean, not that you could stand there and stare at them, watch them grow, but day by day they get bigger and bigger. That's because that unit cell formed microscopically, very, very small, just a few number of atoms or molecules, and everything else just keeps laying in that pattern on top of it. Okay, that's called the unit cell. All right, so those are the types of crystalline structure of solids. The second type, so we have crystalline structure solids, or we can have amorphous. And you guys can probably figure out what that word amorphous means. A means not, morphous means shape, has to do with shape. So basically this has no definite shape. All right? So our particles here are arranged randomly. There is no regular pattern. A good example of this is plastic sulfur, which you're going to be doing a, quote, lab about, watching videos. A video of somebody making plastic sulfur. It's still sulfur. It's still the same element as the powder stuff, same element as the orthorhombic crystals, same element as the monoclinic crystal. But this is amorphous, okay? When you have a solid element that can exist in all these different structures, both crystalline and amorphous, all those different structures are called allotropes. And like I said, we're going to be doing a little lab about that. Okay, so the properties, maybe I'll stop.